So very good evening to all student members. I welcome all the student members for the second module under chapter number 2, types of welding process. In continuation to the previous lecture, in chapter number 2, module 1, we saw the basic introduction to welding process in manufacturing. Now today, we are going to see the various classification of welding process available in industry. So we shall see the outline of the topic. So according to the literature, even though there are different type of welding process with various special characteristics and future, but the main primary aim, apart from various welding process, we need to consider a strong permanent bond through welding operation that tries to improve the structural uniformity and also providing safety by facilitating quick, rapid, efficient fabrication in various industries like automotive, aerospace, and construction. Specifically speaking, the objective of welding may vary according to the process. Say, if you want to go for high volume production, so tungsten inert gas welding, flex core arc welding. So these are the things we can try to either use manually or by semi-automatic or fully flexible automatic mode. So with this few key objectives, we will move on to the main topic of presentation today, different types of welding process. The first one we are going to discuss about gas metal arc welding. In short form, we can say MIG welding. So it is a type of welding process which use a continuous wire electrode, which is consumable type, and also here a shielding gas is applied to protect the welded joint from atmospheric contamination and other oxidation problems in order to join the metals together by forming a strong bond. The following materials recommended for this welding process, say steel, aluminum, and cast iron. These are the materials that are highly recommended for performing the gas metal arc welding. How this type of welding process works? So the metal arc welding comprises of a welding gun nozzle. The spool of wire is fed into the gun nozzle. When the trigger is activated, a continuous amount of arc, electric arc is created between the end of the electrode and the surface of the metal workpiece. So the continuous amount of arc creates high intensity of heat. So this applied thermal heat conduction try to melt the wire electrode and also the base metal. Thereby we can able to form a strong welded joint by interfacing the two materials. In addition to that, a shielding gas which will try to exit the nozzle gun, thereby it creates a protective cloud around the electric arc. So this gas prevents the foreign substance to enter into the molten slag. It acts as a protective gland. So here the consumable electrodes serve as both electrical conductor and also the filler metal to build up the joint. So next type of welding process in connection to the metal arc welding, gas tungsten arc welding. It is TIG welding. So, which comes under non-consumable tungsten electrode. Here, the inert gas, which is considered to be a shielding in nature, which tries to produce the high quality, clean, and aesthetic, more pleasing welding joint. So, this type of welding is suitable for stainless steel and aluminum, especially for connecting thin section area of components. So in this process, an electric arc is created between the non-consumable tungsten electrode and the metal workpiece, which tries to melt both the base metal and the filler material. The filler rod is manually fed into the molten weld pool in order to add the material for the weld. So the inert gas, say argon gas, which acts as a shielding gas, which tries to prevent the molten weld from oxidation and air contamination. We can able to control the arc intensity of the weld and also the filler feed rod by manually coordinating with both the hands of the weld operator. So this kind of welding requires highly skilled manpower to execute the welding operation in the shop floor. Next one is shielded metal arc welding. It's nothing but stick welding. So it is a manual arc welding process which tries to connect the two metal with the help of the consumable electrode with the coated flex material. Electric arc is produced between the electrode and the workpiece material as per the figure illustration which is given on the other side of the column. The flex coating tries to vaporize due to the continuous heat and it will try to protect not only the welded joint and also a successive welded interface joint is produced without any pitfall. Thereby, it forms a molten slag layer over the solidifying weld. How shielded metal arc functions. Arc ignition is produced with the help of the welding electrode. When the welding electrode is initially touched to the base metal, it tries to create a short circuit, then immediately pull back to establish a stable electric arc. So due to the continuous intensity of stable electric arc, the heat is generated from the electric arc. So this helps to join by connecting the base metal and the electrode by melting fusion process. Next type of welding process we are going to see now is oxy-fuel welding or oxy-acetylene welding. It is one of the gas welding type which uses high temperature gas flame created by burning a mix of oxygen and a fuel gas, say typically acetylene, for fusing the base metal. In this process, either using the filler metal or without using the filler metal, we can able to carry out the oxyacetylene welding operation. The process involves heating, brazing, and cutting the metal. The equipment used for this welding operation, it is relatively cheap and easily portable, but the productivity of welding operation is very slow. The quality of the welded joint is also literally very lower compared to other welding classification. So how this type of welding operation can be able to function? So here are some of the procedural guidelines that are given as listed below. So the gas welding comprises of a gas mixture. So oxygen is mixed with a fuel gas along, say, acetylene to generate a hot flame. When the torch touches the base metal, it tries to produce the flame. The flame tries to increase the heat intensity. So this heat will try to fuse the molten metal by connecting together as a permanent joint. Finally, the welded joint will begin to solidify by cooling process. Next advanced type of welding is laser beam welding. So here in this type of process, the metal workpieces will be connected with the help of high intensity laser electron beam. So this type of fusion welding can be used for mass production industries like automotive aerospace due to high speed accuracy and other automation potential characteristics. A high performance laser beam generates a constant energy source. So through this energy, the heat is released. So the developed heat energy will try to connect the adjoining sides of the metal workpieces by fusing it together. So this is the simple working principle of laser beam welding. Next one is resistance welding, which comes under electrical type. It is an electrical welding process which connects the metal by applying mechanical pressure and passing the strong electric current through the material which has to be joined with the help of the resistance according to the current flow direction. So it generates heat and fuse them together. The common type of resistant welding is spot welding and seam welding. These are the two types which comes under this category. And this type of welding is considered to be very cost effective, used under high automation and environmental friendly with less pollution. There is no gas is involved, entirely electrical energy source. Here the pressure is applied with the help of the electrode by mechanically touching the part to be joined. Parallelly, the electrical current is passed through the circuit, so that will try to activate both the electrode and the workpiece material. So the localized electrical resistance is set up across the circuit so that creates intense heat by causing the metal to become molten state. So thereby, due to that pressure, it forces the molten metal to join together by forming a strong interface between the two workpiece material. So with the above information, what I mean to say is that even though there are different diversity application of welding process that may vary according to the wide range of material and the purpose of usage in different modern industry which are available today. So no individual can say that this welding process is best, that one is best. It is not like that. Each and every welding process has its own unique features and potential characteristics. Among all, we have to see carefully before choosing any welding process the factors like material type, thickness of the material you are going to weld, which type of weld joint you are going to adapt, required weld quality, then the budget you are going to use for equipping the various welding infrastructure gadgets, and moreover experience of the labor about the welding process. These are the most important factors to be considered on time. Understanding the above techniques is considered to be one of the most essential for selecting the most suitable method for a given fabrication project in industry. So with this information, I thank all the student members. We will meet in module 3. What are the defects and causes in welding operation? Different types of defects in welding operation and its causes. So thank you all.